Hello everyone. Today we are on to the third lecture of thermodynamics, and in today's lecture we will cover work done by the gas in terms of expansion or compression, that is basically pressure volume work. Now first let us understand what is work. Work is basically a mechanical way of transfer of energy. Like if we talk in terms of a gas, for us the gas is the system. If the work is done by the system, it will be negative. Work is done on the system, it will be positive. So if it is done by the system or on the system, the energy is getting changed. Energy is being transferred. Okay, so let's understand that, but before that just make note of this, that work done by the system is negative. In the previous video we have discussed about heat, so the same is the case here. There we studied heat by the system, given out by the system, minus on the system, heat taken by the system, positive. The same is here. Work done by the system, negative. Work done on the system. If the work is done on the system, it will be written with the positive sign. So there are two ways by which the energy of a system can be changed. Either heat or work. Okay, heat given by the system, absorbed by the system, work done by the system, work done on the system. Okay, now we will be first talking about the work done in terms of compression or expansion. For that, let us consider we are considering a cylinder. There is a cylinder, and the cylinder is fitted with the piston. It is fitted with the piston. It's basically a frictionless piston. Means it can go up and down. This is a piston, frictionless piston. And here we have taken a cylinder. Inside this we have taken gas. Inside this cylinder. Okay. Now there are two things. One, the work can be done by this gas. If it is done by this gas, this piston will go up. In that case, the pressure inside the gas is more. Here there is a pressure, which is pressure of the gas, which is being exerted on the piston, and here there is pressure external, the external pressure which is acting on it. So if the two are equal, the piston will not move. If we are considering case number 1, where we are saying pressure of the gas is greater than the pressure external. If the pressure of the gas is more, so if this is more, it will try to push the piston up. The piston will come up. Now suppose the piston has come here. Now it has gone up. This was the original position. Let the volume initial be V1. Let this be the initial volume, means the inside it. Okay, and here it is now say V2. Now it will be the whole volume till here. Okay, there is increase in the volume. So first we are considering this case where gas pressure is more than the external pressure. In this case there will be expansion of the gas. Okay, now let's first find out what will be the formula for the work done by the gas in expanding. We know that work done is equal to force into displacement. In physics, that is what we study. Force into displacement is work done, right? And we also know that the pressure is equal to force exerted by the gas per unit area. So instead of force, we can write here as pressure into area. Okay, and suppose the displacement, this is the original position, and the displacement in the piston is this much. This is the displacement in the piston. Let the displacement we are writing as say dx. We write down this much dx. the displacement in this is say dx. Then the area, now it is not a flat, it's actually a circular cylinder where the area of the gas, the area of the cylinder multiplied by this distance by which it has moved up. This product can be written as the volume. This we can write down as change in the volume. So we can get the formula P into delta V. What is the delta V? The change in the volume. In a way, this is equal to P into V2 minus V1. That is the change in the volume. Right. In this particular case, when we are talking about the expansion, the delta V is positive. The delta V is positive in this case in terms of the expansion if we are considering. Right. So work done, if this is positive, that means the overall work here comes out to be positive, which is not right. As per our convention, the work done by the system is negative. So we write here in the formula itself, work is equal to minus P delta V. Here minus P delta V. So what is the pressure what is the formula we are going to write down for work? Work is equal to minus P delta V. Now you can put the value here. This is positive. So this is positive. That means the overall work done by the system in expansion will be negative. This will be minus P delta V. So work done will be negative in the case of the expansion. Clear? So in this case where the work is done by the system, the energy of the system, the gas lowers. Energy of the gas lowers. It is transferred. So basically work is done means mechanical way of transfer of energy. Energy is transferred from here. So energy is transferred in moving this piston up. So work will be done by the system. This is one case we have considered. Now let us consider the second case. Now this is the second case we are taking, where this is again a cylinder, piston, frictionless piston, and there is gas inside the container. Okay. So here there is external pressure acting on the piston, external pressure, and here there is pressure of the gas. If both are equal, the piston will not move. We are considering second case now, where the pressure of the gas is less than the external pressure. External pressure is more. If the external pressure is more, what will happen to the piston? It will come down. The piston will come down. It will come down. Let this be the initial position. Here V1. Why we are writing here V1 means if the position of the piston is here, what will be the volume of the gas? This much will be the volume of the gas. But now when it has come down, what will be the volume of the gas? We will say this will be the volume of the gas. So now the volume is V2. So final minus initial we have to take. So what will be delta V now? Delta V in this case will be V2 minus V1. V2 minus V1, where V1 is greater, so the delta V is negative. Delta V is negative. So same formula we are going to apply, but before that just see, if external pressure is more, one thing is for sure that there will be compression. There will be compression. The piston will come down. So we'll now calculate the work done. Work done is equal to force into displacement. Again, we are getting that final formula which we wrote earlier, minus P delta V. Now we know that delta V is negative in case of compression. If this is negative, this another negative means overall you will have work done as positive. So you'll get the formula now that the P delta work done is equal to plus P delta V. In this case, the energy of the system will increase. Okay, because it is being pushed down. Is this point clear? Now, at times you are asked a question with reference to the graph. Right. See, suppose you are given like this. A graph is there between pressure and volume. And then these, readings are marked over here. And suppose it is said that object moves from point A to B. What is the work done in this? What is the work done in moving the object from the point A to B? So how we will calculate this? in moving the object from point A to B, the work done will be the area. The work done will be equal to the area under that PV curve. PV curve or PV graph, whatever this line is there, below that whatever is the area, that is the the work done. So how do you calculate the area below this? Means in a way, if you extend it below this, in this area we have to calculate, and then in this curve, whatever area is coming under that curve, we have to calculate the area of that, and that will be the work done. Okay, now first thing is to find out what will be the work done, we will have to use this it's a trapezium. This is a trapezium. So how do you calculate the area of the trapezium? The work done, that will be equal to the length of this parallel side. This is one parallel side, this is another parallel side, so length is 2. Here it is 6, so it is half of this length of one parallel side, that is 2, plus the another parallel side, that is 6, right? This, and into the height of this, that is this one, this height of it, that comes out to be 2. So you can just solve this. It comes out to be 4 here. Okay, this is 8, and this is 4 into 2, that means 8, and this is pressure and volume, so that means we will write down 8 liter atmosphere. Okay, now one thing, from A to B, volume is increasing, that means delta V is positive. Delta V is positive means work is done by the system. By the system means you will write down with the minus sign. And this is in liter atmosphere. This is in liter atmosphere. You can just make use of that relation. That relation says that 1 liter atmosphere is equal to 101.3 joules. So accordingly you can convert this into joules. You will have this as minus 8 multiplied by 101.3. This much joules will be your answer. This much will be the work done in moving the object from point A to B. This is one question we have discussed. Is this clear? Now suppose you are asked like this. This is one curve they have drawn. Okay, this side is volume, this side is the pressure, and you are asked to calculate the work done in moving the object from A to B. Second, they have asked in moving the object from B to C, work done in moving the object from B to C, or the work done in moving the object from C to A. Okay, so how you are going to calculate? Work done in moving the object from A to B, there is no change in the volume. When there is no change in the volume, we know the work done formula is equal to minus P delta V. No change in the volume means there is no work done in this. In this case, in moving the object from A to B, the work done is 0. In moving the object from B to C, pressure is this 6, and how much is the area under that? This whole area we are going to calculate in this case. Below this line, what is the area? That we are going to calculate. That means this length from here to here, it is 6 multiplied by, what is the difference of this? 2. So this into 2. That means answer will be 12. From B to C, volume is increasing. That means it will be minus liter atmosphere. And that I have already told you how do you convert that liter atmosphere into joules. So this can be done. In moving the object from C to A means the area below this. This area we have to calculate then. Under this line, the area. That will be the work done by the system in moving from C to A. So it's again a trapezium. So work done will be equal to half length of the two parallel side, that is 2, and this is 6. So 2 plus 6, right, multiplied by what is the difference here, that is 2. That means it is 8 8 by 2. That is 4 into 2. That is 8. So here the answer is 8. Just check it, is it minus or plus? C to A. This is initial, this is final. Volume has decreased. Work is done on the system. That means answer will be plus. Plus 8 liter atmosphere. This much is the work done. Is this point clear? Now in the same question, suppose you're asked, calculate the work done in moving the object from A to B to C and then back to A. A to B, B to C, C to A. Okay, A to B, B to C, C to A. That means in moving this whole, whole path, what will happen? The work done, will it be 0? No. The work done is not 0 in this. You can just add up and see. You can add up the whole thing. 0 from here to here, from here to here, minus 12, from here to here, plus 8. Add them up, you are getting minus 4. So the work done is minus 4 liter atmosphere. In a cyclic process, the work done is not 0. In a cyclic process, the work done is not 0 because work done is path function. It depends upon the path followed, not only on the initial and the final states. Clear? Now, suppose you are asked a question like this. Calculate the work done when 1 mole of a gas expands from 1 liter to 5 liter and the external pressure is this. Simple. You know the formula. Whenever work done is asked in terms of volume and the pressure, you are going to use minus P external into delta V. What is external pressure? 1 bar. So 1. What is the change in the volume? 5 minus 1. 4. So your answer comes out to be minus 4. Minus 4 liter bar. Minus 4. This is in liter. This is in bar. So 1 liter bar. Minus 4 liter bar. That is the thing. And of course you can convert it. 101.3 joules. You can multiply with this, which already I told you, because 1 atmosphere is nearly 1 bar. 0.987 but you can take it as almost 1 bar. So you can multiply this with 101.3, that much joule will be your answer. Right? Okay, I hope you have followed. Now one question I am giving you for practice. You can try this out on your own. Suppose you are having a graph like this and you are asked to calculate work done in moving the object from A to B, work done in moving the object from B to C, work done in moving the object from C to D, work done in moving the object from D to A, and also A, B, C, D, and again coming back to A to B, C, D, and again coming back to A. That means from here it begins and it comes back to this point. What is the work done in this? Okay, so you can just calculate their work done. Their values are given here. This is 1, 2, 3, 4. That means this corresponds here. This is 4. This is 2. Here 6. Make it a 6. 2, 4, 6. And you can write down the answers in the chat box. Is it fine? Please practice whatever we have discussed in this video and the previous videos of thermodynamics. Okay, so we'll cover the remaining topics in the upcoming videos. Thank you.